Hello everyone, welcome to Learn Overflow. In this video, we'll look into another LeetCode problem that is the furthest building you can reach. Okay, it's a medium level problem and let's see what this question is telling us. It says you are given an integer array heights. Here you have the representing the heights of the building, okay, and some bricks and some ladders. So you have some bricks, you have some ladders, okay. You can start your journey from building 0 and move to the next building, possibly by using a brick or ladder. So you can use either in building a brick or a ladders to reach the next building. Okay, let's see more into this. While moving from building I to building I plus 1, so it simply means from one building to another, and it says it's a zero index array. So that's the it's about the array we have. If the current building's height is greater than equal to the next building's height, you do not need a ladder. Okay, so if we are moving down, we don't need a ladder or a brick. Like you do not need a ladder or a brick. So if our current building is greater than equal to the next building, that is we are moving down, we don't need anything. Okay. If the current building height is less than the next building height, so that means whenever we are moving up, that time you can either use one ladder or hi plus 1 minus hi of bricks. What I think h means basically is our heights array. Okay, so it simply means hi plus 1 minus h. So the tallest building height minus the smaller, like this, our current building height. So that's the difference we have. So that number of brick we need to use. Okay. So in the return, we need the furthest building index, like the zero index, you can reach if you use the given ladder building optimally. Okay, so we need to find out how far we can reach using either a ladder or a brick, and to the which building top we can actually reach. So that's what we need to find out. Remember, it's a zero index, so you can actually return the index we have out of the heights array. No, you don't need to add a one to it. Okay, so that's more or less the question we have. So let's try to understand this example test cases we have over here and find out what is the exact concept they're trying to display over here. So this is our example one. And this we are given an heights array and it contains that 4, 2. So 4, 2 you can see is like going down. So you don't need anything over here. And then 2, 7. In 2, 7, you actually need an something to move up, either an ladder or an particular brick or number of bricks you need to use over here. Okay, then if you find it says 7, 6, in 7, 6 you don't need anything. And then in the case of 6 to 9, that is we are again moving up, we need something over here. And for the case of 9 to 14, we are moving up, we need to use something over here. And then in the case of 14 to 12, we are moving down, so we don't need anything. So we have additionally we have 5 bricks and 1 ladder. If you understand clearly, so this question is all about trying to say that the ladders are valuable for us. Okay, like if you read the question properly, you can see like it is not saying to what height a ladder can reach us. So by understanding, we can take it as a ladder can help us reach a maximum height to any height possible. Okay, so we need to understand the ladders are more valuable to us. We can use ladders anywhere possible. All right, uh, to gain some infinite size of jump, like to gain some infinite jump for us. So we have to keep in mind to use our ladders conservatively. Okay, so the idea is to prefer bricks wherever possible and only use bricks for like only use the ladder when the bricks are insufficient for us. Okay, so let's try to understand this particular example we have here. So it says like the output is 4. Okay, so that means if this is like 0, 1, 2, then moving to 3 and then moving to 4. See, that's the maximum this particular image is also showing. We can reach till this point, right? Till this point. See. Yes. Now let's try to understand the explanation we have. It simply states like we're starting from building 0. On building 1, we don't need anything since this height is greater. So like we're moving down. Then on from to go to building 2, we are using the five bricks over here. Okay, so you must either use a brick or ladder since 2 is less than 7, right? 2 is less than 7. That's what I marked as in green. Then to go to building 3, we don't need anything since we are moving down, right? Over here, we can simply jump and go there. And going further to go to building 4, we use our only ladder. We have one ladder with us, so we use that and we find that we reach to building 4. And then it says it's impossible to go to any further heights. Okay, so one question comes in mind: why we're using bricks over here? If our ladder is of infinite height, we could have used a ladder over here and then moved that. All right, let's try to understand what will happen in such a case. Okay, so in this case they are showing with the bricks. Let's say we use a ladder over here. Okay, I'm just marking with L. Then we use a ladder, we gained all the steps, and then we are at this position. Now we don't have a ladder, we need to go with some bricks. Okay, so what is the difference from here? So if you look carefully, this is the third position, that is the 6 over here. Okay, and then we need to go to 9. So we have 3 bricks. Okay, we have particularly 3 bricks we can use for this case. And how many bricks we are left with? We are left with only 2 bricks. Now post this fourth position, where we can go, like can we go to from 9, can we go to 12, 14 with using our 2 bricks? No, it's impossible to go from 9 to 14 using 2 bricks. We need at least 5 bricks for that, but we don't have 5 bricks. So that's why you can say that we may have bricks left with us, but we cannot reach any farther than the fourth position or the fourth building, like the fourth indexed building. Instead, it's like the fifth building though, but yeah, it's the fourth index building starting from 0. So thus it says like it is impossible to go beyond 4. Okay, so the idea is to find the place where we use the maximum number of bricks. Okay, and instead we can like we can change that bricks, like the thing I did with the ladder to it, so that we can regain those many bricks and can be used at it, right? But yes, that's anyways you can reach to a particular position in this particular, like in this exact example. If you interchange the number of bricks and like bricks and ladders to the position where they're used, you'll reach the same place. But in case if you find that somewhere you have used too much of bricks, and then say like after this fourth ladder, that is the 9, like after this 9, if we have something like 10 or say 11, or like if you move from 10 to 11, then we may have used like bricks over here, right? So for that case, we should have used a ladder in the initial case and then changed the current or orientation we have over here. So that may be a possible case. So that can be a corner cases as well. So without wasting further time, let's write some code thinking of this corner case. Like if we have an array like this, like 4, then say 2, and then 7, then we have 6, then we have 9. Say we have 10 over here, and we have say 11 over here. Okay, so in that case, if such was an array for us, if we have used 5 bricks at this position, then we should have reached till 9th, right? If we have used 5 bricks. But if we have used a ladder at this position, remember we could have reached the end of the like the array. Like the whole array could have been traversed if we have used ladder in this kind of situation. So we need to think of that. So the basic idea is that if we like find the place where we use the maximum number of bricks, and then change it to a ladder so that we can regain those many bricks, and that can be used ahead. So like that's can be an corner cases. Okay, so let's go ahead and write the code for this, and then I will in a minute I will explain you what exactly we are going ahead with this, and how we should find a solution to this. All right. So here we try to like conceptualize the code in the exact manner what we thought of doing so. So let's understand this code line by line. In the first line, you can see I just found the length of it, then took a variable brick use that will help us to keep a mind of all like how many brick we have used so far. Okay, going further, we have a priority queue. This queue will be storing like all the brick used counter. Like whenever we are using some bricks, it will help us to store that counter for us. Okay, so that will be the use of the brick, like PQ priority queue, and then well, so why like one more question is why we're using priority queue over there so that we can find the maximum brick used at some position. So as in the example I was saying that if we have like a maximum brick used at any position and we find that we can move further using a ladder at some position being a corner case, then we will use the maximum brick used to replace that with our like ladder at that position and then go ahead with our bricks or count we have ahead. Okay, so that's the basic idea behind this. Now let's move further. We are going through a loop being going to each of the element of our heights array. Okay, and then what we're trying to do is we are finding if the heights reach being I took a variable reach that will help us to point to what value we could reach till now, right? To what index we reached till now. So that will be the final return answer for us. Like that's the reach, like how far we reached so far. Okay, so that's the digital value. And then moving ahead, we are going to this condition that if the heights of reach is greater than equal to heights reach plus one, that is the when we are moving down, if the height is going down, so we just continue saying that we don't need to do anything any further. If this is not so, then we'll move ahead in our code. What that is, we'll look first to calculate the height difference we have here. So the building height difference, like how far we need to jump. Next, we see that if a brick used plus or height difference is less than the total number of bricks we are given for with us. So if that is the case, that if the brick used is less than equal to number of bricks we have, then we just simply like say that the brick used counter is incremented by the height difference, that we have used this number of bricks so far, and we add this difference to our priority queue, that this is the maximum this is the current number of bricks that we used here at this position. Okay, and remember the priority queue always if we just pop any elements from the priority queue, it just stores the maximum elements in our like the top of the queue. Okay, so that's the benefit of using a priority queue. Now what else we have here, then that's the one we used for bricks. Okay, now we'll use for our ladders. So whenever there is a brick, we will go ahead with the brick is there, we'll simply keep on using brick as much as possible. That's the initial case we have, that we will prefer bricks whenever possible, and only when bricks are insufficient, like only when the bricks are insufficient, that is lesser in number, then we go for our ladders. Okay, now we go for our ladders over here. What do you find? That we just simply if insufficient, we need to use a ladder. So that's the basic condition, that we use a ladder over here. Okay, but we have a small corner case check for this thing. The corner case I was discussing just a few minutes back. The thing is, if a priority queue is not empty, okay, that means it has some elements in it, and that basically means our priority, like we have used some bricks previously to jump to some height. Okay, and the pq.peak, that is the topmost element on our priority queue, is greater than our height difference. So it simply means that we need to move ahead, like the height difference we have over here is greater than the maximum number of brick we used before. We used earlier at some point, right? So there's the maximum number of brick we used earlier at some point will be given by this. And we check that if this is greater than our height difference, the current number of steps we need to go ahead. So if that is so, then we use, like we simply take out that top element and add, like we subtract, like from a brick used, we subtract this top element that we consider that we haven't used that much brick there. Rather, we have used this height difference brick, like the current height difference we have over here. We use this much and we add a height difference to a queue. And what we do is basically like this. Let's take this example on our left. Example being, say we had this like array over here, right? So let's consider the same array. We say we have 4, then 2, then 7, then 6, then 9. Okay, and thereon it's not 14, 12. Say we have only 12, like only 11 over here. Okay. Now see what happens. So from going from 4 to 2, we don't need anything. We are rather going down. So it's the case of this. Okay. Now from going to 2 to 7, we will use a break over here, right? That's the if condition we have over here. So we use something like, say, we use exactly over here we used 5 bricks. Okay, so I'm marking bricks with yellow. Now see what happens further. In the further step we are going from 7 to 6. That is again I'm going down, so we don't need anything. Now at this position from going to 6 to 9, what do you find? That a priority queue has an element 5 in it. Okay, so our priority queue has an element 5 in it, right? That's the kind of priority queue have. And you find that here we need how many bricks? Here we need 3 bricks exactly, right? That's the requirement of number of bricks. So we find that a priority is not empty, so it has element 5 in it. And we find that now, the PQ to T, that is the 5, is greater than the height difference. Height difference here is 3. So if that is so, we just do like our brick count have like a brick used was we had used 5 bricks, and we go ahead like from the 5 bricks we subtract like brick used, we subtract the priority queue pole. So we just taken out this number of 5 bricks from that brick like the brick used till now variable, and then we just added this height difference. So we added 3 to that. And then we add 3 to our priority queue that we used a brick over here now. And now we replace this position with our ladder, right? With our ladder we have. So that's the basic idea of what we did. And so we used one ladder anyways. So we just put in a ladder minus minus. So that's how we reduced. And what if neither of the cases there? That means we don't have enough bricks or we don't have enough a ladder with us, then we break. Like we cannot go any further. If that's how we reach there. So that's the maximum point we can reach over here. So let me just submit the question once and let's see if there are any kind of corner cases that I have missed out. Like it was all good. Like all the time I was thinking like there was a small mistake in the priority queue. So I'll tell you what. All the time I was thinking of this stuff like it should be like the largest element at the top of the priority queue, right? But priority queue stores element, like the normal priority queue stores element, like the smallest element at the top. So usually priority queue is like a min heap concept. So something I missed over here was like collections dot reverse order. So we should make it a max heap rather. So like when you do collections dot reverse order, it stores the maximum element at the top. So that's where you can see. I just now ran this code over here, and you can see it like completely it's got submitted. So that was all about this question. So I hope you can understand how you can complete this question right over here. Okay. So thank you all for watching this video. If you have any doubts related to this question, make sure you just comment below and also hit that like button. It gives a lot of motivation to me for more videos like this. Thank you all for watching this video.